Hello, this is Captain Chaudhari. As you know, I've been doing the videos on basic calculations of basic understanding of stability calculations, which would be most useful for pre-C and second mate candidates. I have already done about 15 of such videos. This might be the 16th one. In my last video, we talked about the principles of trimming, how the ship trims, and we had done the derivation for MCTC, that is moment to change the trim by 1 centimeter. In general, trim related questions, they can be handled with a very simple use of two basic formulae, one relating to trim and other relating to sinkage or bodily rise. Basically, a stability student, he fears how many formulae to remember. So what I tell them is you should learn a very easy way of deriving these formulae. Once you have the confidence that you can derive this formula, of course they won't ask in the examination, but once you have confidence that you can derive the formulae, you'll become friendly to the subject. So what are these basic formulae? One is in respect of trimming moment or residual trimming moment. Residual trimming moment that you get, divide by 100 MCTC will give you trim change. So this is one formula. Like trimming moment you might get by shifting a weight forward or aft longitudinally, or loading a weight forward of center of flotation or aft of center of flotation. So whatever is the final trimming moment, the residual trimming moment, if we divide it by 100 MCTC, you will get trim change in meters. And of course, with trim change you have two other formulae, that is TRA, that is the change of draft due to change of trim, is equal to TRC into LCF upon LBP, and of course TRF is equal to TRC minus TRA. So basically there is one formula that relates to trim. Another formula is when we load or discharge, then the weight that is loaded or discharged divided by 100 TPC will give you bodily rise or bodily sinkage. So basically these two formulae have to be used, and in most trim question we must see whether we are able to use these formulae or not. If you are able to make a proper use of this formula, that means you will be able to solve the numerical. In a trim question, you must identify whenever there is change of draft at any point on the ship, along the ship, happens because of two reasons. One is bodily rise or bodily sinkage, and other one is because of trim change alone. In fact, I go to the extent of saying that please understand these two as independent phenomena. One, trim change, and other one is bodily rise or bodily sinkage. Can you give me an example whereby just the trim changes and there is no bodily rise, there is no bodily sinkage? Yes, you are absolutely right. The trim would change purely, and purely the draft change is only because of trim change, and that would happen when we shift the weight in a fore and aft direction. When we suppose this is center of flotation and we are causing a shift of weight in fore and aft direction, this would cause the change of trim, and the basic hydrostatic draft, which is measured at pivot point, will not change. You will find that the ship is pivoting about this point, right? Ship is changing trim about this point, but hydrostatic draft, that is the draft at center of flotation, is not changing. So this is an example whereby the change of draft forward and aft, all over the ship is happening only because of trim change alone. Now tell me another example whereby change of draft is happening only because of the bodily rise or bodily sinkage. There is no trim change at all. Of course, that would happen whenever loading or discharging is done at the center of flotation. Whether we load or discharge at center of flotation, so long as the loading or discharging is happening at this point, there is no change of trim. the ship will bodily go up and down, the bodily rise and bodily sinkage. Bodily rise or bodily sinkage will be uniform throughout the ship's length. So this is an example whereby there is no change of trim, only there is change of draft, which is uniform all over the ship's length. In the calculations also, I suggest the students that we should break the numerical into parts. In the first part, we are causing bodily sinkage or bodily rise. In the second part, we are changing the trim, right? So that I call this standard trim format. We start with initial draft, forward and aft. We apply bodily rise or bodily sinkage, which is plus or minus, and thereafter we apply TRF and TRA, and we get the final draft. So in a certain question, suppose we are doing a loading in the forward part, right? We know that the ship's draft is going to increase and ship is going to trim by forward because we are loading forward of in a point forward of the center of flotation. But we can understand this loading which is done over here in two steps. In first step, we are doing the loading at center of flotation whereby the ship bodily goes down. And thereafter, as if the weight is shifted in forward direction, causing the trim change. So that is what we reflect in our numericals also. And in future, we are going to do some numerical on trim, and we are going to emphasize on this that we understand the process of change of draft in two stages. In first stage, there is bodily rise or bodily sinkage, and in the second stage, there is change of draft purely due to change of trim.